This lesson is for FST, lesson 1-3 on histograms. A histogram is not a bar graph. I want to make that real clear with students right away. A bar graph compares numbers to categories, and typically the bars are separated by space. In a histogram, you'll see in just a moment when we scroll down that the bars are always right next to each other. The data is displaying how frequently values occur, and it breaks up the range into a numerical variable and its non-overlapping intervals of equal width called bins. Students need further details about making histograms, they should read page 23. I don't think it's necessary for students to copy any of this information. I just want to have it as a visual reference to talk about a few characteristics as it relates to histograms. The bins typically are varying in size. Typically you'll see bins that are 5 units wide, sometimes 10, sometimes 100, and you'll need to pay attention to where the inequality symbol is and where the inequality or less than symbol, inequality or equal to symbol is. If this were the bin that you were using, it would indicate that if you came across a data point called 5, you would not drop it in this bin, you'd simply put it into this bin. 5 is not supposed to be included here because there is no equal sign. It would be included here. So when you're working with your data and trying to figure out which bin to put it into, make sure you pay attention to where the inequality symbols lie. Another thing to pay attention to when you're working with a histogram is whether it's a picture of frequency or relative frequency. Notice that the two pictures here are pretty much identical except for that one difference. Frequency shows the number, how many times that thing occurs, where the relative frequency will show the percent of how often that thing occurs. So the frequency shows the number of values, where the relative frequency shows the percent of those. But again, it will not affect the look of the histogram. Your labeling down here again shows that this particular set of bins goes by 5s, and then you have to look for those details of where those cutoff points are going to lie. So again, for example, if 5 was one of your data points, or if a state said that they had 5 representatives in Congress, that bin or that bar that represents the answer of 5 would actually be this second bin here. So if you said I have 5 representatives from my state, that would be displayed in bar number 2. We'll practice that again when we try a specific example using data. A few more items for kids to look up as it relates to vocabulary. Skewed is a very big idea when it comes to working with data. Is the data skewed or not? And that relates to the idea of outliers, which we'll look at in the next lesson. So typically I have students look it up on their own, and then we discuss it over the next few days in class. That also relates to the idea of a histogram having a tail and whether or not the histogram is symmetric. These next two items that I want to look at are not from the textbook. These are simply items that I'd like to emphasize to help students be successful when they are making a histogram so that they can get the full points. It is important that students understand that when they are making or asked to make a histogram, that the first thing they should do is make a decision. They have to choose the bin width, or how big the integrals are going to be. And for a lot of students that is problematic because right away they get paralyzed by trying to make a good decision. Keep in mind that when you're making your histogram, you want to make sure that it's got at least 4 bars in it and not way too many bars. So you want a manageable amount, and that could mean that you might make your graph more than once. So you want to consider, should I make my bins 5 or 10 or 100, and it will vary depending upon what the data size is that you're working with. Also, when making a histogram, you must, meaning there is no other way around it, prepare a frequency table. If you show a histogram without the table, you will not get full credit. So let's go ahead and practice now with 2 examples from the homework. So we're on page 26. We're going to do number 3 together, and then know that I have an alternate form which I'll display at the end of the video. This is a list of heights in inches of 15 students. The book lists the data horizontally. I also have it listed here vertically. Students should copy and take the time right now to do it in their notes, either horizontally or vertically. Some people prefer to have their data displayed one way or the other. Students simply need to copy one of the two. So take a moment to do that and pause the video. Now that you have your data, you need to make your decision. What kind of bin width are you going to choose? As we look at the data, we've got numbers in the 60s and the 70s, one number in the 80s. So if we pick bins that are 10 large, for example, 60 to 70 and 70 to 80, we'd only have 2 bins, which could potentially only give us 2 bars, which is too few. So we need to pick something smaller than 10 as our bin width. If we go as small as 1, now we're going to have way too many. So it needs to be a number between 1 and 10. So some typical options there would be bins of 2, bins of 3, or bins of 5. Typically, a bin of 5 is going to be easier for us to manage than a bin of 3. Most people don't count by 3s very easily, but most of us can count by 5s fairly quickly. So usually if I can, I try to stick with a 5 as one of my choices, and let's go ahead and try that for this problem. If I want to make my bins from 60 to 65, let's just list them all out and then we'll decide where to put the equal sign. So I'm going to go ahead and speed this up right now so you don't have to watch me write all of those. So now that those are all done, we need to go ahead and figure out where we want to put, for example, the number 65. Do we want it to fall into the first bin or the second bin? And there's really no right or wrong here. For my notes, I've indicated that I want to have it in the second bin. So I'm going to display the example and go through this example, assuming that a 65 would go in bin number 2. At the end of the video, I will post the tally table if you decide to put it in the other bins for practice. So let's go ahead now and take all the data and drop it into the bins and tally as we go. Quick reminder for students that when you make your tallies, you're going to tally up to 4 and then you do a slash and then you continue after that. That's what I mean by a tally. And remember, this is your frequency table. So these are your bins, and then your tallies are going to be your frequency. And so I'm not going to actually draw the bars here, but technically this would be a table. So if I go through, I'm going to go ahead and tally all the scores here, and then I'm going to quickly fast forward and show you my results. So I'm going to have my frequency here, and I am going to go through a little bit, I guess, on how to tally. So I'm going to take the first piece of data, 73, and I'm going to scan the list, and I'm going to figure out which bin that would fall into. So 73 is not between those two numbers, it's between these two, so I'm just going to put a tally mark there. Then I go to the next number, 66, falls here, 63, there, 70. So this is one where you'd have to make sure that you put it in the right bin. 70 should not go here, it should go in the third bin down. So now I'm going to fast forward and finish my tally. So now you can see all the frequencies that I got for the entire list of data. Now let's go ahead and draw the actual histogram itself. And for that you need to make sure that you label both the x and the y axis. I'm going to say heights in inches and frequency. Then you need to choose a scale. And for your scale, the scale has already been determined by your bins that you chose. Just make sure you have enough room to show all of the bins. Know that your x-axis does not have to begin at 0. You can simply start with your very first bin. And then we're going to go ahead and choose what would be the most appropriate for our frequency. For that, you'd want to look at your tally symbols and make sure that you have enough to cover all the way up to your highest one. So in this case, I got a 7, so I'm probably just going to go by 1s here, but I'm only going to label every other. And so now I'm going to go ahead and draw my bars. The first bin from 60 to 65 should be a height of 4. The next one is 7, and so on. I'm going to go ahead and fast forward and finish my picture. And I just noticed that there was a mistake here quickly in my frequency table, so there should have been a 3 there, not a 4. You always want to make sure that your data matches with the data that was given. You should have 15 tally marks here, and I think I had 16. The last thing you want to do is make sure that you provide some kind of a title for your picture. Graphs should always have titles, and they don't give us much to go on here, so I'd simply write probably 15 students' heights in inches as the title. Let's go ahead and try one more question. This is from number 11 in the homework. This one already has the frequency table finished. As students look at the table, one thing that I hope that they would notice is that there is a problem or a concern right here with the first column. The bins that they chose to use are not uniform. There's probably a very good reason for that. Maybe they had more people that were in some of these lower categories, and so they spaced them out evenly based on these numbers. But we're just going to go with what they have, and we're not going to critique them. We're just going to draw it as is. We're not going to try to rearrange what was given. But normally your bin widths need to be of equal size or uniform size. And so when you're making your picture here, you're simply just going to label with the information that they gave you. So we wouldn't want to label 1, 4, 14, 15, 24, because those again are not uniform. So we're simply going to use the labels provided. And so you just say under 1, the next one's going to be 1 to 4, the next one's going to be 5 to 14. Just make sure that the spacing used for each is uniform. So just provide the labels that are given. And then in terms of our labeling for the frequency or for the drownings, it would depend upon how much room you have and what you want to go by. You will be estimating here. You will not have a perfect way to show 62. It'll be an estimate. So depending upon how much space you have, you could go by 50s or by hundreds. So I'm going to let students work on that for a moment, and then I'll go ahead and display the answer. So this is the book's answer. You can see that they went by hundreds, and if students' graph looks similar to that, that's perfectly fine. If your bars end up being more skinny than the ones that they have, again, that's also appropriate. I want to point out a couple wrong things to do when you're making your graphs. If you look at the x-axis here, I've given space for 1 grid bar wide for under 1, and then I gave 2 bar width available for the next bin, or 1 to 4. So this would be wrong because the spacing on the x-axis is not consistent. The same thing is true on the y-axis here. I went 1 space up for 100, then I jumped 2 spaces to get to 200 and 300. So make sure that you're consistent in the spacing that you're using. I wanted to show students, or provide students with another option for this particular tally table. Students who had marked the equal sign on the right can see what the tally table would look like for that instead.